and in this topic I'm going to discuss about Android application structure. So what does Android application structure is like? I'm trying to explain you about the project structure, how the application is structured, so I'm gonna explain this pretty much. You can use, you can have a project view or you can have a Android view, and you can also use all these toolings that have Android Studio has provided. Like for example, if you want to navigate to this file, you just need to pretty much select the open file. You just select the open file. If you want to expand all, you just expand it. I have already expanded. So if you want to collapse all, you collapse everything. So by default, like I suggest you to use this Android project structure. So this is how like it's why I suggest you to use Android project structure is because it gives you a pre-selected, like a neat, I need to say it provides you a neat groups of app folders structure. So you can pretty much focus on all the Android neatly structured folder structure. Okay, because if you see in the project structure, you see not only Android but everything like Gradle files, you have the idea, you have a lot more things here. Okay, you have a lot more things here, but Android this neatly structures into basic fundamental concept, file structures of Android is pretty neatly structured here. So I suggest to use this one. Okay, so I want to expand all my file structure of Android, my project file structure, and we will overview all these files with more details about the most important ones. Okay, and let's check out. Okay, and you see the view how it is it looks like is like this. Okay, and okay, so the first thing is like you have the first thing you have is like our Java file folder structure. Here we have where you have your main activity. Your main activity is present here. Whenever your app runs, app starts from this activity. So it's the main activity, right? And okay, so let's try to understand this main activity. What is the structure of this main activity? Okay, and yeah, okay, so the import statement, as you can see here, the first thing you see is the package. This is the namespace where actually your application lies. Okay, and the import statement includes the library, and all these libraries are included here by imported here. The source of what the activity is using, it's like your activity is using all those import, that means it's implementing all those libraries. Okay, so now we go to our main activity class. Okay, which actually it's extending or which is deriving from the class from app compact activity class. Okay, so okay, there is another interesting thing that you have to understand. Like Android uses this character for both deriving from a class, like extending or inheriting. So it can use both the superclass or the inheritance, like the interface. You can just implement your interface here. Okay, by using comma and just providing your interface here. Okay, so this is some little concept. And another important concept is your main activity is derived from Android. Let's go and check out app compact activity. You can just check out your app compact activity here. You see the import of app compact activity um, is derived from android.x.appcompact.app compact activity, which is like it's what's the specialty of this app compact activity is the backward compatible. Okay, it's backward compatible activity. That means it is designed to make your app work also on your older devices, so without any problem. So it is pretty much backward compatible, and yeah, you can, if you want to go and more explore about this app compact activity, you can just read this class file. Okay. And Android activity can have multiple callbacks functions, so you can override this different callbacks. And actually also this is known as a activity life cycle. So activity has pretty much a life cycle, and you can override each and every life cycle active callbacks. Okay, so for this activity we are just implementing on create callback of activity life cycle, because we want to display the screen with the layout, right? So let me also go out okay, you see that we have different life cycle activity, like on destroy, on create, on pause, on resume, on start, everything are on stop, all these are life cycle callbacks. Okay. Okay, so now what we are using is we are pretty much using this only this callback to so display our activity on the screen with a layout. Okay, so actually we have a layout. uh, okay. uh, okay, actually we are also using activity binding here, like view binding, sorry. um, okay, let's focus on the concept, like we have we have here, as you can see here on this save instance state bundle. Okay, if you override, so what is the save instance state? The save instance state, the bundle with the nullable parameter, it's like an Android mechanism for restoring your previous saved state, okay, of the activity. So so for like simple activities, if you haven't stored any state, so the value will be null. As you can see here, the values of save instance state can also be null. So this is like a Kotlin way of declaring a nullable type. So you can also save instance state can also be null. If you haven't saved any instance state, then no need to worry. You don't need to pass anything. Okay, nothing is passed here. Okay. Okay, so finally, also we have a super on create in a save instance state. This line calls through to the overridden method of the base class. So it's pretty much calling your base class method. And finally, set content view, like pretty much I'm using view binding here to binding the root. The root is pretty much like it's referencing to your layout. Okay, so the layout is pretty much activity main, this layout. Okay, for the moment. And so if you don't load the layout, it will display a blank screen, so like a white screen is displayed. For the moment here I'm using view binding, and actually I'm also using a navigation component here, but the main okay, let me check out the project here. My first fragment that I will be displaying, this is actually my first fragment. Okay, actually the view of my first fragment is this one. And fragment first binding, actually, yeah, this is the layout that actually I am displaying, okay, here as my first fragment. All right. Okay, so okay, let's have a look about our more about our let me expand here. Let's okay further look at our application structure. So we also have like example instrumented test, this one, we have this block of code where we write our source code. Okay, this com dot block, this com block, java dot like com. This folders consist of like com niranjan, you see, like, and this kotlin app. This is pretty much structured in this way. You have a com as a folder, then you have another folder subfolder like niranjan khatri, and you have another subfolder like kotlin app. Inside this all subfolders you have your source code. Then finally also you have your example instrumented test. This is like an example of a UI test, so it's pretty much look like this. Okay, let me just please close this one. So this is like an instrumented test which will execute on your Android device. So this is the example instrument test already created by our template, you know and you can check and verify the flow and structure of your app by running test on the UI when the app is running, so you can pretty much run this test. Also there is another structure which is pretty much divided. We have like a source code, we have a UI test or integration test, and we have also our instrumentation test, or we have the unit test, example unit test, you see. And this is the example unit test, and like essentially like you when you are writing unit test to verify your source code is actually working, you just need to write this test. I will be going in detail about in depth about in my coming lecture videos about how to write unit test. Okay, for the moment, like, let's and also I will be talking providing you a lecture about test driven development, how to do that. So I will be doing this in my upcoming lectures, but and so the main motivation of this lecture is just to understand the different project structure, so blocks. Okay, so we already understand what is a manifest in my previous lecture file. So then now we have a source code section. Okay, we have the source code, we have a instrumented test block code block, and then we have a unit test code block here. So you write your unit test here, you write your instrumented test here, you write your source code here. So this is the simple project understanding of a simple project structure. All right, so guys, I think I've explained enough. Now we also further move on to understand more interesting, and this is a java generated. As you can see, you don't need to, this is auto generated by your build system, okay, or gradle, like the build configuration. So you don't need to like, if you check out here, is automatically generated file, do not modify. So you cannot modify, this is auto generated. So this, as you can see here, generated is a java like auto generated files, and like you don't need to modify anything here. Okay, so now let's understand and move further about further to the another section of our project structure, and that is like our we have our like IC launcher, like a drawable. Okay, okay, let's close this and let's understand about the resource section. This resource section actually consists of a lot of drawables, layout, menu, map maps, navigation, graph, values, and many more. So we will discuss one by one. So the first thing is like we have our project structure consists of a drawable, and like we have two drawables. We are like IC launcher background and IC launcher for foreground, as you can see here. So what is this is like these two files together makes a launcher icon of your app in a vector format, which will be used by our IC launcher XML file, okay, in Android and above. So pretty much like this is used by our IC launcher uh, XML file. Here you see that you have a map launcher, and pretty much this is used by the foreground and background drawables are used by this IC launcher.xml file. Okay, And IC launcher is pretty much, you can present, you can see here like your manifest file consists of icon, which is a IC launcher. So whenever you launch your app, the icon that is used is created by this IC launcher XML file. Okay, so this is the concept. Now further on, let's move on to our layout. And what are the layouts like that we have to make sure about is like we have activity the made layout first. So this is the layout file that was created by Android Studio. Obviously when we created our project, it was auto created by our template driven approach of creating Android application, right? And so it's actually main activity is the initial screen of your activity, which consists of actually the app bar layout, your toolbar, your floating action button. As you can see here, we have a floating action button, we have a app bar, we have a toolbar layout, this one, and finally we also have our content main actually consists of a fragment which has a navigation graph, and your navigation graph has pretty much okay, so we will be talking about navigation graph later on, but actually it has a first fragment and a second fragment, as you can see here. So let's not divert our focus on what we are doing, so let's go on of what is the important concept here. So yeah, the okay, let me go also open the emulator. So actually what is displayed here is a fragment. Okay, uh, okay, so the first fragment is being displayed here, and the layout of a first fragment is something, it is, this is the layout. Okay, okay, yeah, this is the layout. Okay, and okay, so like screen displays displayed in Android can be created using XML. Like we can like, okay, so to give you the note, we can create screen displays in Android by using XML that we have created here, or also we can use this kind of UI by creating by using Jetpack Compose. I will be like doing a separate tutorial about Jetpack Compose, how to use it. It's a very amazing concept. Okay, so for building a declarative API, actually it's a declarative API to dynamically build your UI. Okay, so which is pretty cool concept, and I will be just pretty much doing this tutorial in the next video. So let's not divert our focus and let's follow on. So for XML, the documents start with a XML header. Like we can pretty much, now we are focusing on how to build our UI using XML file. So actually everything starts, the layout XML starts with this XML tag, uh, and XML header followed by a top level view group. So what is your top level view group? Your top level view group is pretty much like we are using is a constraint layout, and then one or more nested views and view groups. So we can have one or more nested view or view groups. So like I can see this is a view, text view, and bottom is also another view, or we can also have any view and another view group. Like we can also have more constraint layout, or linear layout, or relative layout, as per your choice. Okay, so as you can see, the text view is and bottom are two children's in our of our constraint layout. So actually test view displays text, as you can see here, it displays the text, and button just displays you the button to which provides you the option to click, right, and navigate or do some actions with the button, right? So uh, actually the constraints, like the view is pretty much constrained. In constraint layout, the views are pretty much constrained, like constraint base of like start to end of the parent, or like like the view is center horizontally, as both constraints are applied. For the moment in text view, if you see the constraint, like, okay, let's understand in Okay, let me close the emulator. And okay, I am not able to see the view here. Okay, actually, if you see this text view, hello first fragment. Actually, the constraint is what is applied here is top to top of parent, and is start to start of parent, end to end of parent, and bottom to top of parent. So this actually the constraint layout handles the position of your child views in the base of the layout. Okay, so this is the concept that you have to understand. And similar goes with another view, another child view. Okay, so now let's further understand in detail about what is a like a constraint layout. So there are three XML namespace inside our view group constraint layout. That is XML NS Android, XMLNS app, and XMLNS tools. Okay, what are these one? So XML and XML NS Android, this refers to the Android specific namespace, and it is used for all attributes and values within the main Android software development kit. So it pretty much refers to the Android specific namespace. Okay, so all the attributes and values within the main Android software development kit is provided by here, whereas XML NS app, the namespace is for anything not in Android software development kit. So in this case, constraint layout is not part of the main Android SDK but is added as a library. Okay, so it's added as a library. It's Android X library, you know, as you can see, a material design, yeah, material design library. So you know, you see that this the namespace which is outside of Android SDK is just declared here. And finally, this XMLNS tools, it refers to the namespace used for adding metadata to the XML, which is like pretty much like for example, if you see here tools context, okay, dot fragment, it is pretty much used to show that the sample text visible in the previews. Like when you visit the preview, you just see the fragment. Okay, okay, so yeah, this is just the concept here. Like for example, when you for in the navigation graph, if you see the preview, you have a first fragment and second fragment, right? So these are pretty much provided by the tools. And okay, so there is also another interesting concept here, is like we have this two important. So every layout, yeah, every layout in the sense like every views or view groups consist of two most important attributes of Android XML layout file are Android layout width and Android layout height. Without the, if you don't specify layout width or height, your view is not gonna be displayed, because it needs, every view need to have a dimension, right? And the dimension is provided by the width and height. Okay, so this is very important concept, guys. And uh, also like actually, you know, when you define the layout width and height, like you usually okay, like you set it with the absolute values, like density independent pixel. Okay, that scale pixel size to be roughly equivalent or different on different density devices. Okay, like density in pixels can be also denoted by dp or dip. So most commonly when like we, as you can see here, we are using some attributes like match parent, or like for the moment here we are using match parent, but we can also have a wrap content. Wrap content pretty much it tries to takes is its original size, whereas match parent is gonna take the size of the view group where it is displayed, okay, of its parent. Okay, so and wrap content is will be as big as required to the only enclosed to its content. Okay, so uh, yeah, that's the concept here, guys. And yeah, as you can see here, the text view is pretty much using wrap content, right? So it will pretty much be displayed. Okay, let's check our emulator. You see the size that the text view is pretty much using is just this size. um, the view, it is just mm, taking the space or the area according to the like how big as your content is, right? For example, if this text view size increases, it's gonna take the extra size, right? Until the size is like based on like it can grow, the wrap content size can grow on the basis of the content. Okay, so this is the important thing that you have to understand. Whereas the match parent is like pretty much like, you know, is the our view group constraint layout is pretty much taking the entire space area. And you see the button is pretty much just taking the exact size of how big the your content is, right? So that's the concept here. Okay, so actually, you know, we can have, as I already told you, we can have multiple view groups. Okay, and based on like your application requirement, we can have like linear layout that can be like oriented vertically or horizontally, or you can have a frame layout which is usually used to display a single child view, and you can have a relative layout which is like kind of a simpler version of constraint layout, okay, which lays out views positioned relative to the parent and sibling views. Okay, so we are done with the layout. So now we can have the another interesting concept is also our this IC launcher, you know, that I was discussing before. This IC launcher, as you can see here, is a .webp files. Okay, what is a .webp launcher icons that have it is like it's like icon that can be for every different density of device. So actually this image format webp webp, okay, webp format is created by Google and has a greater compression compared to the PNG images. So it is like more, it provides more greater compression than the PNG images. Okay, so uh, so WebP images were introduced later than Android API 26 Oreo. Okay, so uh, so guys, to target different one of the note that you have to understand is to target different density device on Android platform. Beside each one of the IC launcher.png, you will also need to see like different density target, like you need to also have like drawables which is pretty much targeted to the different density. Okay, so based on your so because as you know that as device vary widely in their pixel densities, like so Google has created some density buckets so that correct images should be selected to be displayed depending on how many dot per inch of the device that your device has, right? As you can see here, we have a multiple dimension uh, we can have a multiple dimensions. There are different dimension peaks density qualifiers, and we'll be explaining in detail. So actually we used like the baseline is the MADPI. Okay, so that is a medium density screen. Actually it is of 160 dpi. So less than the medium is the low density screen of 120 dpi. No DPI is like a no density independent resources. You can also have no DPI, that means a no like it's a density independent resources. You can have a high density screen of 240 dpi. You can have like this is a high density pixel of 240 dpi. And you can also have a XS dpi is like extra high density pixel. And you can have more extra high, and you can have an extra high, and you can have any dpi pixels, of any dpi. And you can also have a tv dpi, which is pretty much for television, like resources for television. So but the most important concept that you have to understand is like the base dpi, the base density bucket, was created at 160 dot per inch for medium density devices. So that's why it is called MADPI. So this is the baseline. Okay, so on the baseline of this density pixel, all the other baseline other density pixels are calculated. Okay. um, so guys, maybe I can, okay, let's provide us the, okay, let me see if I have okay, so let me go to the Android version here. So okay, to give you guys some interesting concept, to calculate, okay, to calculate so actually if, what is the main concept how to calculate the density pixel? Okay, is like you can take the baseline as a 48 uh, uh, by 48. This is like a, for example, yeah, if you have a bitmap drawable that is 48 by 40, but this is like a is for medium density pixel. Okay, so it's like a medium density pixel, which is like one which is pretty much like one times the baseline. Okay, so one times the baseline. So um, whenever you have a bitmap of 36 or less than 36 by 36 pixel, then these are low density pixels. Okay, because this is actually if you multiply, it is pretty much like uh, 0.75 times the baseline, right? Like because it is less than the baseline, right? And similarly you can calculate like if you have a 72 by 72, you can have like it's a high density pixel. Okay, it is pretty much like 1.5 times the baseline, 1.5 times the baseline. Okay, so this is how to get the idea of how to calculate the density pixel. So if it is 96 by 96, it is pretty much like a extra high density pixel, which is pretty much like 2 times more baseline. And similarly if you have 144 by 144, like if you have a bitmap of 140, which is extra as dpi, high density pixel, extra high density pixel, which is pretty much like 3 times the baseline. And similarly it goes with the 192 by 192, which is like extra high density pixel, which is pretty much 4 times the baseline. So yeah, the rule of like the main rule that you have to understand is like always you need to have follow this scaling ratio principle, like okay, let me put the baseline here. So the rule is pretty much here every times, this is the rule, like this is the baseline, and you just pretty much, if you it's less than the baseline, then it is LDPI. If it is more, 1 times more, 1.5 times more, or 2 times more, 3 times more, or 4 times more, it's yeah, you can calculate on the basis of how many times your density pixel is, right? So yeah, this is the concept, guys. I hope it will be really helpful for your calculation of or comparison between the different physical launcher icons that you want to select for different devices, right? Okay, so now being said this, we further move on to the other concept. Like, we are still in the resources. We have finished the drawable layouts. Okay, we are not going to talk about menu. We have already talked about the mip maps. Now we are not going to talk about navigation, but we are now going to talk about like I will be talking about navigation in the another detailed concept, which is pretty much regarding the navigation, jetpack navigation that I'm going to implement. Okay, so now let's talk about the some basic fundamental concept that you are about Android application structure that you are learning. So the okay, let's talk about the colors here. So in colors XML file, you define the colors you want to use in your application, and the colors that you define is in hexadecimal decimal format. Okay, so hexadecimal format. Okay, so actually the format is in okay, the format is in this form. Okay, so actually the format is in ARGB format. Okay, what is ARGB format? It's like alpha. A stands for alpha, R stands for red, G stands for green, and B stands for blue. Okay, so actually the all this structure, like the hexadecimal format of assigning the value of a color, is defined in this format. So alpha, or also you can say transparency, can be from can be from, actually alpha can be from 0, like I can say 0 to the maximum of ff. Okay, starts from 0 to 0, so you can assign any value. So ff means like you it's completely transparent, like almost like you have a uh, transparent. Okay, completely uh, okay, so actually 0 is completely transparent. To ff is like completely opaque. Okay, so let's try to add this value. You see, it's completely opaque. The value, you see that if I assign this value 0 0, it became completely opaque, and now it became completely transparent with this color values, so you can pretty much play with this kind this color values here concept. Okay, and actually same goes with also the other values, like the other values are starts from two values for you should actually, you know, your color hexadecimal consists of 8 values, two for each values, you know. So alpha consists of 2 values, red 2 and green 2 and blue 2. So pretty much you see, okay, let me just for the explanation try to just divide its values. So this values is for alpha, this values is for red, this values is for green, this values is the blue, and this is the combination of all these color values. Okay, and now so there is also another interesting concept is like so you can assign any values from 00 to ff. Okay, so 00 can be also assigned to color. That means none of the color is added to markup, so its complete statement means no color is added. Okay, so ff means all color is added, so it's completely so all color is added there. Okay, so this is the concept here. So I hope this is pretty much will explain you like and make you understand more about the concept. And now let's further move on to other resources, like we have now we can also have dimensions, like you can have your dimensions in density pixel, you know, so that you just don't duplicate your values. Just you assign a value here once and just you can utilize it everywhere. And similarly your dimensions like we can also have a string resources file, and this string xml file displays all the text displayed, okay, in your app. So every text that is displayed in your app is just you just need like it's like a group of text that is displayed in your application. So it's like a container which consists of all the your string resources that your application is using. And this way of implementing the strings in a strings xml file will help you to not duplicate your code, or it will also help you to write, for example, your if your app is a multilingual app, and then it will help you a place to customize your text whenever you want. Okay, and so it's also by adding string to this resource file, strings.xml resource file, you can also update the string in one place. Okay, actually it is like kind of a it is just in one place. So whenever you can modify your strings pretty much easily in one place. So you don't need to navigate or search for the exact location, you know. I'm like search for the particular string and just modify it whenever you modify. It is pretty much helpful for clean programming. All right, so finally you also have a themes. And actually themes commonly, like we I've also discussed the thing, like explained it this when I was talking about the material design concept. But commonly all the styles which are used throughout your application are added in the themes here. Like you can see here I have added no action bar style here, like app overplay style, you know, different styles, and you can customize your styles as per user need, and you can add there. Okay, and yes, finally I think I have explained each and every concept that we need to know about the application structure. And thank you very much guys, and catch you in the next lecture.